Hello students. Next let us look at some problems wherein we try to find out the period of a signal. So determine if the following signal is periodic or not. If a signal is periodic, determine its fundamental period. So here we are having a signal x of t cos t plus pi by 4. Now we all remember, or we all know, that the basic condition for fundamental for periodicity is if there is a signal x of t, then for a period of capital T it should be equal to x of t plus capital T. So we will use this particular formula here, wherein already x of t is given. Next we will try to find out what is x of t plus t. Therefore x of t plus capital T is equal to cos of t plus pi by 4 plus capital T. And for the signal to be periodic, the condition is that x of t should be equal to x of t plus capital T. Therefore, now we have got the equation cos of t plus pi by 4, which is x of t, should be equal to cos of t plus pi by 4 plus capital T. We know that cos of t is periodic with a period of 2 pi. So for this to be valid, the condition is that t should be equal to some multiple of 2 pi, where m is basically integers. Therefore the fundamental period is equal to, when m is equal to 1, so t is equal to 2 pi. This is a very simple problem, and we already know that any cos signal will basically have a fundamental period of 2 pi. Now let us have a look at another problem. So first we will find out what is x of t plus capital T. Now what you have to remember is that it will basically have cos of pi by 3, and then it is only getting added with small t. So I will write t plus capital T. So small t plus capital T. And similar is the case with sine pi by 4 small t plus capital T, which now I can expand. Within the brackets, and I will get cos of pi by 3t plus pi by 3 capital T plus sine of pi by 4t plus pi by 4 capital T. Now this is the signal x of t plus t. Now according to this problem we have got two conditions. The cos waveform also has to be periodic, the sine wave also has to be periodic. So based on that, the condition for cos is, so x of t should be equal to x of t plus t, and cos of pi t3 plus sine of pi by 4t should be equal to the second part. So for the left and right hand side to be periodic, we can say that this portion should be equal to this one, and for that we have to take care that for which pi by 3t should be pi by 3t should be equal to 2 pi or multiples of 2 pi. The condition is that this pi by 3t should be equal to some multiple m of 2 pi. And similarly for the second case, for the sine also to be periodic, this pi by 4t should be equal to some multiple of 2 pi, but now since I have already used m, I will use some p times 2 pi, because m cannot be same for both the cases. So from this one I will get that t is going to be equal to m into 6, correct? And similarly here, if I want to find out capital T, I will get T is equal to P and that 4 into 8. So P into 8. So T is some multiple of 6 and P is some multiple of 8. So what is the value of T such that it is same for both the cos as well as sine? That is the question. And for that we have to take the LCM of 6 and 8. If you take the LCM of 6 and 8, so if I take the LCM of 6 and 8, I will get 24. So I can say that m6 will be equal to 24 for m is equal to 4, whereas p into 8 will be equal to 24 for p is equal to 3. So if I take t is equal to 24, then both these will become, that means both of these values will become 2 pi multiple. That means for this case, this will become, when I put m is equal to 4, then this will become, that means this value will become 4 into 2 into 8, well 2 into pi, which is 8 pi. And if I put the value of t is equal to 24 here, then I will get 6 pi. And we know that 6 pi is also a multiple of 2 pi and 8 pi is also a multiple of 2 pi. So this will be as good as cos of pi by 3 as well as sine as pi by 4. So for both of this to work out, the common value of t will be the LCM of 6 and 8. And that is what is the solution for this one. So the time period is basically 24. So how do we write this? Therefore, at t is equal to 24, x of t is periodic. And you can check this. That means if you substitute for t here, if you substitute 24, and for t here you will substitute 24, then you will get this value as 8 pi and this value as 6 pi. And that will automatically make this cos of, we know that cos of any value plus any multiple of 2 pi, any multiple of 2 pi. That means whether it be 2 pi, whether it be 4 pi, whether it be 6 pi, or whether it be 8 pi, any multiple of this will be equal to cos theta itself. So both the left and right side will be equal. Now let us look at the next problem. So this is another question where we have cos of t and sine of root 2 pi, or sorry, root 2t. So let us find out what is x of t plus capital T. So from the equation we will get cos of t plus sine of root 2 t plus capital T, which I will write basically by opening up the bracket. I will basically write root 2t plus root 2 capital T. And for periodicity, we know that x of t should be equal to x of t plus capital T, that is the right hand side will be cos of t plus sine of root 2t should be equal to cos of t plus capital T plus sine of root 2t plus root 2 capital T, for which the two conditions are that t should be some multiple of 2 pi, and for the second case root 2t should be some multiple of p 2 pi, where from here I will get that t is equal to m 2 pi, no problem, and here I will get capital T is equal to p 2 under root of root 2 pi, where 2 and root 2 will basically cancel off and we'll get a root 2 on the numerator. See, now we want to find a common value of t. Just like we did in the previous problem, we want to find out the common value of t. For that, we can try to find out what is the LCM of 2 pi as well as root 2 pi. But the problem is that the value of m and the value of p has to be an integer. If p and m have to be an integer, that means the value of the LCM that we are going to find here, that should be in such a way that it should be an integer, which is not the case. As we can see here, you cannot find an integer which will be the LCM of 2 pi and root 2 pi. Because if you find out what is the LCM of 2 pi and root 2 pi, I can say that the LCM is 2 pi. Because if you multiply 2 pi with 1 and root 2 pi with root 2, then you will get the value as 2 pi in both the cases. But we want the value of m and p to be an integer, and we can see that this is not going to be an integer. That's why the signal is not going to be periodic. Another way of looking at it is through the ratio of both these being a rational value, for which we can write ratio of these, the ratio of this will be m 2 pi divided by root 2p pi, where pi and pi will cancel, root 2 and 2 will get cancelled to get root 2, and we will get the value as m by p into root 2. So let me again write this as the ratio is m 2 pi divided by p root 2 pi, which basically gives me this, is irrational, is an irrational number. Why is it an irrational number? Because here p and m both are integers, it's not an issue, but root 2 is irrational number. Therefore, the ratio is going to be an irrational. Therefore, this signal is not a periodic signal. If you look at this ratio for the previous problem that we did, if you remember the previous problem, in the previous problem, here if you would try to take the ratio of these M6 and P8, so M6 and P8, we can see that basically this will give us 3 and 4, and still if M is an integer, M into 3 will be also an integer, and P is an integer, so P into 4 is also going to be an integer. Therefore this is going to be an integer divided by another integer, and we know that any number which can be represented as a ratio of two integers is called as a rational number, and all others are called as an irrational number. So you can see here that this is going to be a rational number. So but we didn't write that here because there was no need to write that separately. So that is what we have done for this problem, and for the next problem we had done, and we have found out that the ratio is basically irrational, so this cannot be a periodic signal. Now you might be surprised because cos is actually a periodic signal and sine of root 2t is also a periodic signal. Then how come the combination of both the signals are not periodic? Well, they are not periodic because there is no common multiple at which both these signals become periodic, and that is the reason why we have got the ratio of both the capital T as an irrational number. Let us look at the next problem. So here we have got xn is equal to ej pi by 4n. Now this is a signal which is discrete time. So we know that x of small n plus capital N will be equal to e raised to power j pi by 4 n plus capital N. Let me write that neatly, from which I can split it apart and I can write e raised to power j pi by 4n into e raised to power j pi by 4 capital N. And for the signal to be periodic, and for the signal to be periodic, the condition is x of n should be equal to x of n plus capital N, from where we can equate both the equations as this, where both the equations will be equal if this becomes equal to 1. So I will write e raised to power j pi by 4 n should be equal to 1, and we know that for that to be equal to 1, it will be equal to 1 only when we have e raised to power j 2 pi. That means I will write or pi by 4 capital N should be equal to 2 pi or some multiple of 2 pi. So let me write it as a multiple of 2 pi. So since here already we have used n, I will use m. So it should be some multiple of 2 pi, from where I will get or capital N is going to be equal to m8. So what is the value of m? Any value of m. And what is the lowest value of m? The lowest value is going to be 1. Therefore the signal is periodic. Therefore the signal is periodic with capital N is equal to 1 into 8, 8. Now you might be confused, why did I take m here? Actually there was no need to take m. I just continued what I did last time. because we take the case of m when we have multiple values of 2 pi that can be taken. Here the lowest period will be the fundamental period when value of m is equal to 1. So I will write m here and I will also write m as 1 here. So basically I will get n is equal to 8. See, when I write m, the same signal is periodic with 2 times 8. So it is also periodic at 16. It is also periodic at 8 3s are 24. It is also periodic at 8 4s are 32. So for multiple values of m, the periodic signal will be a periodic signal at different values of m. But the fundamental period will always be for m is equal to 1. When we have two components, obviously the two components should have an LCM. That's why we keep m and n. Next, let's do another problem. Here we are having a problem x of n is equal to cos 1 by 4n. Therefore, let us say x of n plus capital N is going to be cos of 1 by 4 small n plus capital N, which I can expand it out as cos of n by 4 plus capital N by 4. For the signal to be periodic, the value of n by 4 should be equal to 2 pi or some multiple of 2 pi. And for that case, I will write 2 pi m. So now, therefore, n is equal to 8 pi m, where remember m should be an integer. It should be an integer. There is no other way. Now, we also know that n should also be an integer, because in case of discrete time, the value of n is an integer. So if I have to take care that n is to be an integer, then 8 pi m, when m is an integer, should also be an integer. Okay, so I will write that the value of n that I have got is 8 pi m is not an integer. Is not an integer. Therefore, the signal is not periodic. That means x of n is not periodic. That means we cannot find a value of n which basically gives a value of small m which gives the value of n to be an integer, and since that cannot be, this signal is not going to be periodic. Now again, you might be surprised that it is written cos of 1 by 4n, and we know that cos of a signal is basically periodic in nature. Yes, the cos signal is periodic in nature, but there can be a sampling rate in which the samples that we get, they are not actually periodic. Next, look at another problem. So here, one of the first things that we can do is we can expand this signal, because it is cos square theta. So I can write that x of n is 1 plus cos 2 theta, which is pi by 4 small n divided by 2. And then we are having the second equation, which is x of small n plus capital N, that will be equal to 1 plus cos pi by 4 n plus pi by 4 capital N divided by 2. For periodicity, we know that x of n should be equal to x of n plus capital N. or 1 plus cos pi by 4n divided by 2 should be equal to 1 plus cos pi by 4n plus pi by 4 capital N divided by 2, for which we know that this portion, that means pi by 4 capital N should be equal to 2 pi, or n should be equal to 2 pi divided by pi into 4, which gives me the value of 8, which is an integer. Therefore, x of t is periodic with n is equal to 8, or the fundamental period equal to 8. So like that, you can now select more and more problems and try to solve on your own. Thank you.